Hello, Ashman, welcome back to some more Kerbal Space Program. So I turn up my own. Let's continue. I will turn up my brightness too. And I can actually see. Anti-flag on Eve. It's unstable from surface, no. Okay, that's all that's currently on offer. Just returned Kerbals back from the surface of Eve that long ago. I'm not going to plant a flag on Eve just yet. I have flags planted on Eve. But anyway, continuing via plans for the I might make a temporary tug just to move a couple of things around in low Kerbal orbit and make sure everything's all topped up on fuel. But not even. It does have a part that I was. Oh, I'm needing one of these. A couple of everything else. There we go. Got one of these. Vacuum Delta V. I wonder if this will be enough for the part. So, the final part that I'll be setting up here. No wait. I will need to send this up separately. Because this will need to go on the Eve transfer stage. I won't be able to use it to transfer 23 tons-ish. Let's just put this rocket. That's one version. Also got okay, why this is. But first, couple of. Actually, probably two if I want to use a heat shield. Size 2. Then I can have a heat shield open. So let's see. Then some struts. Sure, I've got symmetry on. Cool. Symmetry. Yeah. Right. Okay. Some of the angled parts, surely you'll be able to connect. Yeah. Something at least. Dynamics, I guess. We'll put 2 cone. Apart from that, I guess just staging. So, launch clamps and the engines actually at the same time. Oh right, use the couple and use the solid rockets at the same time. This one needs to go first. This will be for re-entry. That can come later, yep. Fine. Yeah, that should be enough delta V. Okay. Let's rename this. I don't know what to call this. Thingy. Naming things is hard, okay. Add that to stations thingy. Now let's just make sure what cow control. Launch controller. Interesting. Okay, so I've got it set to. That's fine if I move them further up. Like editor good, it's at 0. Put on 1. Let's make the undocking happen on 2 then. So that's when the frame activates. Okay. 3 solar panels. Those are 2 different solar panels. Not quite in line. Oh. Go again. I'm back. I probably will get everything set up today. But at least I will have the mission scheduled in the alarm clock. I hope at least. On thrust up. Actually, I don't think I need to put thrust up because I think. Nope, never mind. Thought I had it set to throttle up. Maybe it isn't. It's probably still linked to the main throttle. Okay. You throttle up, then press 1. There we go. That time it works. I will say I'm not a fan of this booster setup. That is not quite lined up. Oh, I've missed the start of the gravity turn, but I can start now. Have a look at my launch. That is relatively low heading. Try to pull that back up, not that much. Okay. Close to 90 degrees. I nearly missed that. This is the other side. This will be moving things within E this time. Oh no, I thought the because I noticed this had a cow controller on the stage. I thought that would have been set up to decouple automatically. Guess not. Maybe to account for like maybe not going full speed the whole time. Sure. Yeah, so there's already one of these on the station. This will be for the other side of it. I'll just need to design one more component. Kilometers, okay. We've got 2 kilometers of delta V left. Worst case scenario, we should be able to just cool. Stability assist for a moment. Yeah, perhaps it's just a bit higher. Go back to pro mode. Okay, that should be fine now. Should probably throttle down. Go to 2/3. Probably throttle down. Now perhaps this is out of the atmosphere now. Just need... okay, I can also get rid of the aerodynamic parts. Past 80 kilometers now. Front. Could be a bit better. Oh. That's our target. Go just... That does match up nicely, pretty nicely with where our current apoapsis is. Further beyond orbit. 7-second burn. We're leaving the nose cone behind. Pointing the right way, quick save. Go. And the solar panels while I'm out. Okay. Finished that. Let's up to apoapsis and slightly south orbit. Close enough to see how far away it is. There we go, that matches up nicely. Not great on the descending node side of things, but we can fix this while orbit first, I guess. But no, that's not what I want the thrust limiter. 3 seconds, that will do. Okay, quick save and some more time warping. Good to go. One. Now that I think about it, there is also some other differences with engines. Some of them have gimbaling different amounts, so that will determine how well they can control. Yep. Just hop around to it. Pistol. It's physics warped, pointing the right way. And warp around to it. And we'll also need just a tiny bit of thrust. Thrust limiter down. That's a bit too much down though. gimbal. Even some more time warping. Four, three. Uh, 0 degrees. Nice. Now, or periapsis, I guess. Fine. Another maneuver at periapsis. Bit more. Nice. 800 meters separation. That will work. Point 6 meters a second. I go to 0.5%. Comes a 3-second burn. A menus for gimbal engines for transfer stage, since fins are enough from ground to high atmosphere. Yep. And yeah, it depends on science and stuff, but reaction wheels are probably the main way in space, because that will allow you to spin without needing to burn the engines, so that you'll actually be able to set up for transfers. And yeah, especially if you're dealing with a larger craft, you'll need the fins themselves aren't necessarily enough, especially at lower speeds or higher up in the atmosphere. So the gimbling engines more use there. It's ones with higher gimbling. Sometimes though you just need the gimbling engines for things that aren't gimbling. Yeah, vector engines are quite useful because you can just place them anywhere. Okay, how... Yeah, second... how close is that looking? Close enough. All the way around. Another orbit. I'm up to it. If you're dealing with some kind of thrust imbalance potential, gimbling's quite useful for that. Don't have solar panels yet. Ah, okay. Target. I feel like you get some basic solar panels fairly early on. Actually it might be tier 3. A bit closer. A bit closer than I thought it would be. I guess I'm controlling the throttle with the thrust limiter. Okay. Bring it down. Okay. Much down then. Let's get target. Yeah. Retrograde. Yeah, are you going career mode or science mode? So let's see, where am I wanting to... Right, so I haven't got the other here yet. We'll be going in one of these two spots, and this one will also need to be... I guess I could do that now. Like one mission away from getting the electronics, yep. Okay. Go from here. Side. Like that. Switch back to this one. Target. Bit wobbly. Bad. A bit of thrust. You're in Korea, you don't know the difference between Korea and science. So, Korea, you have to deal with contracts and funds. Science, you have all the science point stuff and unlocking, but you have unlimited funds, and all your like space center parts start off fully upgraded. Yeah. And I think all your scientists, etc., or all your aeronauts are also all they're all max level. Is I refill out on some that's probably fine actually. Now, switching back to this one. I got a docking port. Which side will need to be? Aim not quite at docking. I'm moving 1 meter a second though. Go. Retrograde, cancel out the velocity. Position myself where I want to be. Dock. Yeah, I mean, I do like career mode for giving mission ideas with the contracts. I would feel maybe a bit undirected without them. That way. Direction is that. Opposite of that one, okay. I want to go that way. That's that way. And yeah, sense of progression is nice. About the direction I want to go. Up. Or this way. Plane. About right. Using a time warp to stop rotation. Or burn this way. Flip retrograde. Okay. And it's just a matter of waiting until we're in approximately the right location. And I'll see again. Pulling the solar panels. Breaking them. Much longer. There we go. Fully cancelled out. Well. Deb came back? Uh-huh. Miraculously recovered from his events. Solar panel. Just slightly. Fully. Yep. Target. That's close enough. Okay. Lost XP. To be honest, not too familiar what happens when you lose Kerbals. That's drifting. Counteracted a bit forcefully then. Pull the prograde marker. Oh, make sure I'm on stability assist. Go. Good. Currently putting closest intercept at 6.5 meters. I'm tempted to time warp this. Time warp a tiny bit. I have sacrificed the Kerbal, they didn't come back. Didn't want him to spread tales of the failures, so he was let go. Not perfectly lined up. But oh, nope, 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 nope. Nope. No. Why? Stop going up. I shift-tabbed to pull up my notes, or to try to move him out of the way. Completely forgetting that would increase the rocket speed, but then I think because of something happening there, It then got stuck on shift, which then just kept rock going up. I think what I will do is move to something else on the map. Actually, go back to the Space Center, and hopefully that will help the jiggly. Hopefully that resolves itself. Back to the tracking center, I guess. Don't really want to quick save if when I get back everything breaks. There we go. Okay, it's fixed. Quick save that. And let's put all the panels back out again. Yeah. So the thing is, sacrifice Chev, it brings good luck. Right. Okay. Yeah. So the intention is that it will be sturdy. It just will need struts to keep everything together. They are not here yet, so they're on the station. To the hab module. Got yep, you can strut in space, you just need an engineer. There's one here. So, if you go here, you will see there's this button. You might need to unlock one of the buildings. It's been a while, so I can't remember. Yes, so this is the EVA construction. Now, to give an example, you can move things around if you want to. You see the things highlighted in green, those are things that you can move with your current weight allowances. You bring more Kerbals, they don't need to be engineers, but if you bring more Kerbals you can lift more mass. You also can't move anything if there's something else attached to it. So you can see I can move the docking ports, but I can't move any of the batteries because something else attached to the child part. You can also put some items in containers, so then that will let you put it back. And hello Asmund, thank you for the follow. Enjoy. Yeah, so that's a brief overview of EVA construction. You can also do EVA construction on the ground, then you become a bit more limited in what you can actually lift up. So, I think now would be time to design the final component. That will be to move the, or to maneuver the the Gilly expansion into place. Fab. Okay, so start up by grabbing station expansion. There we go. So let's pull up center of mass. right underneath that docking port. Let's that strut, I guess. Get the height basically. Well aligned. So I am going to want do impact for weight. Shouldn't be by much. Actually, the struts will have moved. So I will want something that will be attached at exactly the same location. Docking ports. Now, how... the tank up. Add another one. Hatch. To the side. Just. Although that looks pretty close. Tiny bit lower. Tiny bit. Oh. Okay, now let's make this part. That. Actually, that's height. So. Well, actually, no. We will need the combined mass. Now, what I can do here, add a vector engine. Turn that back on. There we go. Up with center of mass. So now when this burns, it should push the whole thing straight. Now, there are some other things I want to do. Mind control will want RCS controls, but then the question is, want that with RCS or with Werner? So, cluster power is 12, compare that to 0.112. I mean, advantage of Werner is that we won't need to bring monopropellant. I will need to bring some wheels. Yes, I can't attach them on top. You might need to go for a larger. Don't need Delta V on this, really. I would certainly like reaction wheels. Just to maintain roll control. And use the earners for the translational. Pop. Well, that. Could put. Now you'll notice that isn't quite centered, but if I use snapping with movement, I can bring that down into the tank. Now put things on top. Copy. Go. If there wasn't any, if there was a node there on top. No. Amount of batteries. Could use the solar arrays there. And just for backup power of or while we're moving it across. Sure. Okay, really expansion. I can name things. Now then, I would like one more engine side. What I can do, 4 times symmetry with. Wind up with central mass. I've got snapping on, so I think I might need a speed actually. Let's remove that one from symmetry. So now I've got 3 times 3 of the Werner engines in the right place, and then the 4th position, vector engine. You can see, I can't really point it out, but you can see that just above the cursor, there's the light green, and then there's above and dark green underneath. Just lining up the lines on both of the balls, center of mass and the one, they'll be in line. Though there shouldn't be too much rotational forces. Now, there will be some amount of imbalance because there'll be Kerbals. Actually put 5 Kerbals. Yeah, that's not too far off. Things up slightly. It's slightly hard to move up. Not. That's. Yep, Kerbals have weight. Any component you put there, what they're holding has weight as well, and anything that you put inside an object also has its weight added. So yeah. Maybe you've seen videos before of it, maybe you haven't. Instead of putting like a capsule in, what you can do instead to save on mass is a service bay with chairs in it. This will be less mass, and so you'll get more delta V out of it. Yeah, Kerbals have mass. Over in the capsules. Now, let's I'll go with an engine plate, which will be under the coupling. Go. Save staging of that, and now put burner engines on the top and bottom. Ability. Now, this isn't quite the center, but again, if I go to snapping on, we'll move it to the center. Down in slightly. Holding Alt, I can copy it. Thing. Not want to attach. Okay. I've not tried to attach a burner engine to an engine plate before. Okay. In that case, go for these come in discs, but I don't think they're going to be right. Certainly not on the last one. Let's go for size 2 parts. Wanting something flat. Yeah, this just changes its colour. Put a rechargeable battery on, I guess. That caps it off as well. Okay, and now let's put an engine on that. Yep. Just move to now that looks centered. Save this. And also integration toggles and disable the original. That will be covered by the reaction wheels. Attach that. Depth mass. And put this in a fairing. How much mass is this? So far it's 26 tons. I think I can get away with a size 2. Coupler. Come back to that in a minute. You want to just test that be able to use for ventilation. So, save that. Ooh. Oh. Guidance unit. That's what I can put underneath. Bit overkill on the drone part, but yeah. Move tool. Snap into position. Yes. So it does seem to be in line there. Definitely be. Although nodes. Does it actually produce thrust offset from its nozzle? I wonder. We want to test that. Coupling. The use of that. Now I will just test it out. So to do that, I'm now realizing the yeah, they might be centered for itself, but they're not centered for sideways translational. Thing. I will come back to that. For now, if I go Alt 12, G, set orbit. We'll be reverting this. That. RCS. That rotates. That one isn't on RCS. Yes, to stable. That does rotate us. Okay, so I think they are producing thrust offset from the nozzle. Interesting. I'm learning things too today. Test that out though. Now if I do the same test, will it rotate? This is one way you can test like of components, make sure that I can add multi-directional RCS, yes, but the intention is to, and I can use the action wheels as well. But the aim is to do as basically put them in line so that then they're not having to fight. SAS isn't having to fight for move. Yes. It is still rotating. Interesting. Another thing that you can, another reason that you would put something to orbit like this is to test if parts are occluded. If you put a plate right behind this engine, for example, you'll notice that it doesn't actually produce thrust even when you turn it on and it's burning. If you're not sure if the part's occluded, you can just put it into orbit and do a test firing and see if you actually change your velocity. Yeah, so if I put SAS on, then you'll notice We're not rotating when I burn, even though we should be. Because of the SAS, but it is having to fight that. You can see the SAS, the oars moving a bit. Especially when you're using larger engines. So, the engine on, you'll see the SAS isn't able to, the reaction wheels aren't able to compensate for it. So reduce it as much as possible, and then you don't have to worry as much. And yeah, then in terms of, could have multi-directional RCS, however, then you're burning fuel when you could be just using reaction wheels, which only use electricity, and so you're not wasting. Now, part assembly. Yeah. And put it back onto. Yeah. Now, center of mass of this as a whole. This is only going to be useful when docking to station, the expansion. Isn't going to be any use once once I'm actually docked to this and trying to maneuver the whole thing. So, in any case, of mass is basically along that section. So, would like to use one of these engines, but I can't for RCS. Controls. What I can do. Structural. Rotate it. That. Position. That's going to be hard to get it centered, actually. So, no, I think that would be. And is along that center vertical. This. Oh. Mine is. Turn off snapping. Push it out slightly. Seems like it could be in line. Now, let's move this from symmetry. Put it out slightly. In the end, I don't know where the actual thrust is coming from. Times symmetry. Around. Base. Honestly, line them up there as well. And for the top, a bit more difficult. Let's do it with snapping, so then I can be sure that the bottom components are at least in the same position. Like Let's make sure they're rotated. Yep, they're rotated. Anyway, good. One. Yep. Out. Slightly in. Yeah, generally it's a good rule of thumb to turn off rotation on your DS control things. No thrust limit, no. Is then what's it called? Chin maneuver up. Could be relatively closely lined up. Now, just to get this into orbit. So, start off by decoupling that. Add decoupler. Size 2 fairing. Now, before doing anything else, what I want to do is line this up, center of mass. I'm just going to pull this up slightly. With the green line and red line all lined up with the center of mass. Bring it back down. Now, build our rocket underneath it. It will be in line with our center of mass. Good fairing. Now we just need to get this to the station. That's nearly 30 tons. Okay. Well, what's a 30-ton booster like? What version 2? Yeah, no. But we'll show this off because this has not quite asparagus staging. I think, yeah, I had enough thrust-weight ratio with these. So I put solid rockets. Get more thrust-weight ratio. I don't know. In any case, I've got these drop tanks. They feed into this side one, so these go first, then the side tanks, and then I've still got the central body. Might be going with that this time. 40 ton will be sufficient. Yeah, don't worry about that. Take that. Okay, oh, I will just... that work. has removed it from his orbit. Save that. I think I can launch that now. Surprisingly, no one with thrust for something that claims to be a 40-ton booster. But I will launch that. Don't talk about its head like that, it's a bit self-conscious. Oh, I need to... No, I can't launch this. I need to get this to Gilly. Same mass. I'm not docking this with station. Give me a moment. I need to send more mass. So, let's pull up the Delta V map again. I will need something that has... I think it's like 3... something like 3,000 meters a second. T plus 60 plus 410. But 2,000 Gilly purely, but getting the Gilly encounter is hard. It's not the size of a head that matters, it's where you manage to send it. Now then, I think I could go for Mark II here. Put a clear engine vacuum, and not quite. Does get relatively good thrust weight ratio. Yeah, nope. Okay. I think I can go for size 2. Of the oxidizer. A bit more. Probably more than that. Yeah. Oh, something like this. There you go. That will hopefully be enough. Not a fan of hopefully enough. This is now 50 tons, so a bit over 50. Okay. What happens if I... Okay, yep. That's fine then. There is a point where the extra mass, because the atomic engine is fairly massive, so that's 3.3 for the Wolfhound. Go with nuclear engine. No, it's 3. Similar mass. Okay, never mind then. Could potentially substage 2. Go overlay. Yeah, that's fine then. That, and put another coupler on. Put an engine plate on then. More mass. And now we don't need a decoupler. So, once again, 50, a bit more than 50 tons. Should have a 50 ton. Not using that one. That seems more reasonable. I believe this way. Struts. Any on 8. Go. Tie us up. It will let me. Go. Okay. Yeah, that should be enough. Now I'll disable cross FIFO. Which engine is that? No, not that one. Lower music to turn up my mic. Okay, I can turn down the music a bit. Is that better? Ah, your engine. I'll go up. Yeah. Go. Here we go. Okay. Aerodynamics up. Fine for staging there. That is not fine. That needs to go. Wait, we've got an engine plate. Same time. Okay. Move that out of the way. Wait. Oh, we don't need the decoupler because we have the engine plate. Okay. Save that again. I think we should be good to go. Actually, wait. Actions. Deploy. Should be good. We don't have any deployables. Ooh, I will want neutrons. Near center of mass just to make sure. Okay. And that should be good enough, I believe. Got batteries, we've got solar panels. Could be everything we need. Even launch. And then just one final small thing, just to move the Gilly expansion station to the Eve. Transfer tug thing. Anyway, thrusters up. We are launching. And we're at Nice standard thrust-weight ratio, so that's good. 50 meters a second, and we can start the gravity turn. And 90 meters a second, we can continue. One kind of rule of thumb is about 5 degrees every 50 meters a second of velocity. But of course it does depend on your starting thrust-weight ratio. And I guess continuing thrust-weight ratio. We are going a bit high. Let's bring that down. And quite often could be alright to just prograde. 38 seconds to apoapsis. Inclination's increasing, so let's try to bring that down again. Degrees, 0.3 degrees. I forgot to pay attention to that. Oops. And so now, and bring throttle way down. Still, till maybe, yeah, 40 kilometers up, sideways. This is still going to increase our apoapsis, but it will help increase our periapsis a lot faster. And probably fine now to deploy. Perhaps this is out of the atmosphere. Aim for about a 75-kilometer orbit with this, because I don't need to rendezvous it. While I'm waiting to get out of the atmosphere, figure this naming, put it priority 2. At our apoapsis. Just this. Bit, just for timing a bit. Should be good. Pretty circular. So about a 10-second burn. So nearly the last step. This one will be going off on its own. Yep. So what's the eccentricity on this looking like? 0.0004, not too bad. Now we can do It just says to Eve. Okay, let's create that. Node is in 316 days. Okay, so that will be... I mean, it's before the return to Kerbin. Lunar capture is in 3 days. Okay. So nearly ready. Now, just one final small tug of main Eve station. And then assembly in orbit. So this will be a fairly straightforward thing. Just moving a couple of modules from point A to point B. Ooh. Wonder actually. I look at the tourist return. I think I've got this docked at the moment. It's only got a docking port on one side. I guess I could go for a design with a Bravo end or something. That could work. So I knew. Let's start off with docking port. Docking port senior. On one side we'll have this. Go size 2. Should be enough fuel. An idea. No oxidizer. Then I'll go for size 1. Where is it? Here we go. Mark 1 liquid fuel. 3 times symmetry. And that's a vengeance. Oh, okay. I think I do need to go larger, but only so that I can actually fit everything on. Back to size 2. I was using. There we go. I will need a tiny bit more room. There we go. Go with something like that. I can't change those colors. Oh well. It's fine. Go look at fuel delivery overlay. Yes, that all works. Good. And on this side, a undercoupling. It is. So, grabbing arm of the center. Then go robotics. See, I can go like this. There we go. Then I will be able to put more grabbing arms. Okay. Down. Then what I can do is have something size 2 parts. Have something down like this. It will get attached to this grabbing arm, and then these grabbing arms attached as well to help secure. So I'm realizing I did make a slight mistake with my setup. I could use fuel from the final stage, but it's a bit awkward to do that. So because I've got basically the side of, I've got 2 parts that will be connecting with my tug, interplanetary tug, and both of them, one side has a docking port on each side, and the other one has a docking port and then a capsule. Now the issue is, the side that has the docking port is the side that's going into the tug. So I won't be able to dock to it and put it into position. So I will connect to it to transfer across, and then to put it into position, use the grabbing arms. Go with that. On 2, I will have toggle the engines. Actually, maybe 4 and 5. I will go activate, shut down, and then 5. There we go. So, load tug. Change root part. Give it a control guidance unit. Put some batteries on it. Solar panels. Then reaction wheels, because everything needs reaction wheels. Should be fine, probably. Let's give it an extra set just to be sure. Save that. Mass. Let's. I don't need the oxidizer. Mass 40 tons. The oxidizer. Don't really need all the liquid fuel. Split them up into 2 separate. There we go. Yeah, that's way plenty. If I'm going to be moving something around, so I'm only going to be moving around in low curve and orbit with this. Save that. What's mass? Less than 30 tons. I reduce mass further, get it down to 25 tons. Doable. Split that around. I think I can go with that. Let's enable staging. Yeah. stage and V's as well. That's aerodynamic enough, right? Oh well. Let's see, what else? Right, struts. Oh. Pretty good, yep. This is aerodynamic enough, right? Screams aerodynamic to me. Probably. Fine, right? Battle launch. Should be able to finish getting into orbit with the nuclear engines. Hopefully. I did everything correctly. Upside down, so let's set the tab module target. I pressed switch 2, didn't I? Back to launchpad. Probably it's not a lander, good, so it's going to be a probe then. Oh. Switch back to it. No. Tab module set as target. There we go. So, what is the phase angle? 80 degrees. Let's go to 50 degrees. So I'm just going to time up a bit. Maybe 45. 45 degrees. Quick save at 55. We'll need less maneuvering. Once we're in orbit. So SAS on, thrust up at max, and launch. And let's pin the side tanks. I'm only getting audio out of my left ear. That is upside down. North is at the top. Everyone knows north should be down. Okay, everything's slightly reversed. And things are a bit wobbly too. Let's just put on prograde and have a look at that inclination. Try to bring it down. Oh, mine fuel's about to run out on the tanks. Catch them, and now back to trying to decrease my inclination. Don't like that wobble. Oh, no, no. Oh, we got too far away from prograde. Okay. Let's try to recover things. And stage and okay, parachutes. I might have enabled them a bit early. Go downwards and slow down a bit. Yeah, I might rotate, so it'll be a bit easier for me to understand and be more used to it. So one of the critical points will be 4 kilometers. Slow down a bit before then. Okay, there we go. Drogue shoots deployed. Now slowing down. And we'll be hitting 1 kilometer soon. Go. Main shoots deployed. To get a bit lower. And then try to cancel out any remaining velocity. Yeah, wobble gets everyone sometimes. I was hoping that I had enough struts, but I think I need more higher up. Okay, that's... Ooh, nope. Nope. Did not go well. Yeah, it's... because you need to get to about less than 5 meters a second, but if you go too slow and start going up, then you lose control and then you'll hit the ground even harder. So it didn't quite get the right speed. Yeah, keep in mind those parachutes aren't designed to also carry the full heavy rocket and then also payload on top of everything else. They're designed to carry a nearly empty the stage. Well, I will recover those at least. What remains. So some nuclear engines survived. Oh, we got some probe part. 926 funds, woohoo. And let's get the debris as well. Down. I was expecting to lose the engine, I wasn't expecting to lose the whole thing though, at that speed. So he just landed a rocket at 100 meters a second in water. So it can depend, is that 100 meters a second vertical speed or horizontal? That include horizontal speed as well. Maybe you've got things set really high for tolerance. Okay. Let's make some adjustments then. I do have plenty of budget saved up. Though it is a fair bit lower than it used to be. I think at one point I was up above 11 million. I'm down to a bit less than 7 million. That is an Eve return vessel for you. think the Eve return mission alone costed something like 4 million. And I've yet to actually get the return, so I haven't got the contracts are still active for those. Let's see. Tug. Down twice. And add some more struts. I wonder, can... Spare... I can... come on. Up here. I'm sure that won't get in the way. Get in the way. Interesting. But a few of those did not attach. What? You know what? Let's just pretend that makes sense. Sure. Save that and launch again. There's a rocket with a booster still attached and it fell in like a bottle of water and nothing broke. Oof. Let's give this another try. Okay, thrust up. And, it's gone past. Okay, let's... And 3 for now. We'll eventually get around to cleaning up that 3. Either of them. Yep. Degrees. I'll go for 50. Run a quick save. Bust up and launch. Rocket. Yeah, that's what happens when you get a bit too far off from prograde. You do, depending on how much gimbling and other vector control you have, you'll lose control. Okay, so heading of 90 nearly. On prograde for now. Track of that. Nation's 5 degrees, 0.5 degrees rather. Bring that down. And fuel's about to run out, so prograde. Patch. Now I've got less control, so further away from prograde, less, or more likely I am to spin out, especially with an unaerodynamic front. That's giving drag to the front, which means it's wanting more to turn. Unstable. Go back to orbital information. Yeah. Try to keep it pointing up a bit more. That is turning a bit too quickly, I feel. An additional higher set of fins does the opposite of helping to avoid spin out. That makes you more likely to spin out. Oh, I am also just noticing I am missing a fin on this side. Yeah, it's me. Yeah, adding a set of fins at the front will basically increase your drag at the front, and any kind of deflection will cause an additional torque to further deflect you. Having fins at the back means that if you get deflected away from your heading, they will add an extra torque to correct you. Yeah, no, I'm losing control of this one. Okay, yeah, I probably need a fairing then. Okay, let's at least use up some more fuel, decrease the weight. What, 30 seconds. So let's bring that down to 20 seconds. Oh, actually, enable crossfeed. Although, no, that's all just liquid fuel. We can activate those engines though. Now, burn off some more fuel. So, if we kind of look at this as if it's a force diagram, we want to draw it out. Can I add... don't think I can easily add a drawing thing. Turning this on again. Yeah. Oh, that. Still got some fuel. Tiny bit of oxidizer. Okay. Maybe this time it will survive. And on the air brakes for just a tiny bit more. That's logic explained like that. Almost every rocket I launched had fins up high. So actually, if you watch Matt Lawn, he talks. Look up his airplane SSTO design stuff, and he'll describe how to design airplanes in KSP, but the aerodynamics involved are the same. No, 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 I don't want to go up. Go down slower. There. Nope, I ran out of fuel. Ah. Okay, well, go back to the spaceplane hangar. I will give a brief crash course in aerodynamics and stability. might not be getting... I don't think it's a bug. I think it's just I've got a heavy rocket and not enough parachutes for that. But anyway, so I will pull up my SSTO. Show you some plane aerodynamics. In career mode, I definitely recommend SSTOs because you can take off from runway, launch something up into space, and then come back with basically all the same money. So, not the Catarang, here we go. Now, there's two things here. Center of mass. If start off with leverage, the further away you are from the center of mass, everything's going to want to rotate around the center of mass naturally. If you ignore aerodynamics, everything will, if you impart a torque anywhere, it will rotate around the center of mass. The further away you are, basically your torque force is going to be your force times the distance from the center of rotation, and that will be the cross products. That means basically you just take the vertical component, which you can get with the cosine of the angle of your thing. But let's just assume we're dealing with right angles. Then it's just the distance times the force. That will give you your torque. So force near the front here, which is further away from the center of mass, will be more of an effect than torque near the back here, where we're closer to the center of mass. Now, also bring up the center of lift. So you can see here, when you're designing a plane, you're going to want the center of lift to be in line with the center of mass, but you'll want it to be behind the center of mass. Now, in a way, we've kind of got a dart kind of thing here. I do have some small winglets at the front and some elevons there, but I'll get to that in a moment. Suppose you're traveling straight forwards. Your relative air velocity is going to be in line with your direction, basically. If you're traveling prograde relative to the surface, it's going to be the air is going to be coming in straight lines. If I select the whole thing and rotate it like this, and the air is coming horizontally, now the air is going to be hitting the wings and being deflected down. That's going to push our plane back up. We're pointing down, and we have pins like this. The air is coming like this. It's going to push the plane back down, back to the stable position. We ignore having fins at the front, and we're only looking at having fins at the back. That's how it works. And the same for side to side. We're moving like this, and we've got fins. That's going to deflect us back to center. And likewise, the other direction. Now, if we have things at the front, we don't have any fins at the back, and we only have fins at the front. If we get deflected, that's then going to go. We don't have any fins at the back, and we only have fins at the front. Now, this is going to be deflected. This wing surface is going to be pushing down, air's coming like this, it's going to then be deflected down, which will push upwards. Now, because it's ahead of our center of mass, that's going to make us go even more upwards. And so, yeah, basically, you don't want fins at the front because that will further deflect you. Now, there is a reason to put elevons at the front, because, yeah. So, yeah, basically, fins at the back, that increases your stability. Fins at the front, that decreases your stability. Now, there is use to having decreased stability, because that means you'll be more maneuverable. So, you'll be able to actually lift up more or pull down more with the front elevons compared to the back ones. But you still want your plane as a whole to be stably built. So one thing as well you should test if you're building a plane is what happens if you're using up your fuel. You don't want to end up in a situation where your center of lift is ahead of your center of mass. Again, as I was talking about for torques, if your center of lift is behind the center of mass, that's torque behind the center of mass, and so you're going to be stable. It's going to right you. If your center of lift is ahead of your center of mass, that's going to be destabilizing you. So it's the same thing with a rocket. If you're launching straight up, instead of the wind coming from the side, it's coming straight down. You've got the same effect, basically. You want stability, you want everything, all your fins to be at the bottom. Fins at the top will destabilize you. So, commercial aircraft are designed to be stable. Fighter jets, though, they've got computers controlling, doing fine adjustments. They want to be unstable, so then they can maneuver quicker. That's a brief crash course on aerodynamics. And so hopefully that helps you and you don't put fins at the front as much. Now you might then be thinking, well, SpaceX, they've got their Dragon or whatever, I don't know what it's called. They've basically got something this, and then they've got some fins like on either side. Now the thing is, they have a lot better active controls, so they'll be able to do minute adjustments to keep things from going off. But they also they're using grid fins. So if I pull up my thing adjustment, basically they're having it be, they can adjust it so that it's in line with the airflow, and then they have the actual rear ones which are sticking out more. And then when it's returning, they're having the fins at the top because they're returning, and when they're returning, the top is actually the backwards part of the rocket. That's because it's falling down. The engine side is the side that's its direction it's traveling in. Yeah, hopefully that helps. Yeah, so what I did here, it's, if you're wanting to make it yourself, it's fairly simple. I just have, I'll reconstruct it. I have a small structural part. Might be that. Yeah, looks like it. The cubic octagonal struct. And what I've done is, if I go to aerodynamics, this is a bit later on in the tech tree, in order to get the smaller elevons. And basically what I've done is there we go. I'll attach one elevon and then I will offset it. So if you hold shift, you can offset outside of parts. Then elevon 3. I've mirrored it, then just attached like that, basically. Again, offset to the sides, but then it's in line with these components. Rotated them to be all kind of in line like that. Then I've just copied this, placed another one, and moved them up. And then you've got everything's attached to this octagonal part. So if I move this, it moves all of them. And then, except this isn't quite properly set up. But once you set it up correctly, then you can just put it into the sub-assembly, drop it in there, and you can just place it on any rocket. I am not a teacher, no. I do software. Software development. I do enjoy learning, and I have learned from other KSP creators, just watching YouTube videos and all. Into an orientation where I can actually show you. This is basically all it is, and they have quite a bit of good stability. Because you're basically getting a bunch of fins all in one package. And it does mean that you can have side boosters without the fins being interfered with, and also having fins in multiple directions. So, for example, if I have this, so I can have parts on the side here, and normally you wouldn't have the vertical direction elevons because the boosters are in the way. But this way I have those vertical ones, the ones in like this plane. Or I've even got multiple of them. Yeah. I have a degree in computer science. I want to be a dev too. I'm not sure computer science degree is the one you want for development. I mean, it helps compared to a layperson. But yeah, I did software engineering. I'm not a snob, I swear. Yeah, I have heard people with just the computer science degrees having the job market being a bit saturated, and especially if you're new to software or just recently graduated, whole AI craze being a thing. People going, oh, we don't need juniors, right? We can get an AI that does junior level development, and then not actually being able to do anything. So you're not growing any talent, and your AI is creating a whole bunch of mistakes. Anyway, let's put a fairing on this. Yeah, I'm not going to finish assembly today, I don't think. I guess I'll save that for next time. But I would like to at least get this into orbit. Targets have certainly declined. Now. This off. But I guess I'll go for size up, size 3. Go a bit wider on that section. I want to be flat there. There we go. Just above the engines, come in more. There we go. Infamous, really aerodynamically sound rocket. Yeah, I mean, having just open nozzles on an engine, that's how you do things, right? And yeah, I'll need a coupler, but on the opposite direction. Size 1.5. go. There we go. That's now attached to this section, and now I can attach struts from the base here to the rocket. That should be more stable. Let's go for that, so we're not seeing the fairing expansion. Attach to... to the fairing. There we go. That should be fine. There's a bit more mass. So, go back to fairings. Let's add a bit more fuel to that top section. Not much, just a bit. Go with that. Big head was the answer, big head is salvation. I'm actually thinking I should put some more fins on that bottom section. Because currently I think any fins are occluded by the big head. That is the downside of big heads. They can occlude aerodynamics. Once we're loaded in, I will... I was confused there for a moment. Let's revert back to vehicle assembly. Okay. Now, let's get rid of those basic fins. Let's put in a couple of grid fins. Grid fin. 2 times symmetry, there we go. Then I was going to move it in, but with how much that's sticking out, I think I'll leave them. Okay, let's save that. Looks so stupid, love it so much. The yeah, massive front end. So remember how I was talking about having fins at the back is stable and fins at the front is unstable? Yeah, so it kind of works the same way with drag. If you've got some big thing causing drag at the back, that keeps you stable because it pulls everything back. And if you have drag at the front, that makes you unstable. Yeah, I wonder where all my sources of drag are when I'm going this way. And I will need to come here and this on and launch. Another thing, I've got all these elevons and they are in the direction that I want to do the gravity turn. So that is probably the direction I have the most control in. But let's start that gravity turn. A bit below the 90 degrees, so let's try to bring that back up. 90 degrees. Let's not forget to pin the side tanks. Up, bring up. So look, this okay, 2 degrees, or 0.2 degrees inclination rather. It's fine. I don't like how quickly we're turning. It's a bit more than that for 5 degrees per 50 meters a second. That is a lot more controllable. Okay, up to 0.4 inclination, so let's try to bring that back. Oh. Why? That's not right. Oh, staging's messed up. Give it a second. Felt slow. Explains it. Yeah, staging's messed up. I think, let's check the priority 20. Also at 20, yeah. It's 15. That should fix it. Yeah, don't detach that when I'm detaching everything else. Just side boosters. Okay. There we go. And frankly, that doesn't need to be detached until. Okay. This time. Pretty sure that was working earlier, but after making the adjustments. Anyway, this time we will get into orbit. $50 meters a second. How to get that 90-degree heading earlier on. Yeah, let's pin that shortly before I run out of fuel in the side tanks. Because they will just keep burning, but we don't need that thrust weight anymore now that we've burned off all their fuel, and we don't want to have to carry that extra weight with us. Try to fix our 1 degree of inclination. Point 1 degree now. Go back to the useful orbital information. Time to apoapsis is increasing, that's good. Got a bit more code. Bit less thrust weight normally would have, because this is under mass. Payload's heavier than it's potentially originally designed for. Now, I am going to go for more of the higher apoaps compared to getting rid of periapsis. I'm using nuclear engines, which are not good in atmosphere. And this will be dropping before it gets into orbit. 40 degrees now. Apoapsis is up at 46. Once it gets to 50, I think. Prograde, yep. Yeah, it is ahead. I'm going to need multiple orbits to actually get the encounter. Which probably means that Virginia capture is going to happen before I get the encounter. Oh well, I will at least get this into orbit before ending the stream. Oh, I stopped paying attention to apoapsis. I'm going to need a... Yeah, there's not much room under the 80 kilometers that this is in. My only real option going to higher orbit. I could go for 71-kilometer orbit in space. I should have deployed this. Oh well. Actually, no, I was already up enough. It's minute 16 on that burn. Let's check which engines. Yes, phase 4. Yeah, I will be ending shortly. Minute 16. Most of this is going to... Probably more time is going to be spent with nuclear engines, so rather than going for... I was going to say, rather than going for the 45-ish seconds, 40 seconds-ish, I will just start burning ahead of time, but that's basically when it ended up burning anyway. Okay. Stage. Do a bit of physics warp as well. We're in orbit. I will watch the deorbit happening. Okay. Get rid of it. New maneuver. Yeah, probably the timing. So I started early for burn early. Oh well. Quick save. Yeah, it's still there. It's still actually in space, so that's good. The 5-second burn. Oh, 5 seconds before node meant. And now in orbit, and we will eventually get a thing. So let's just add a maneuver, set it to be in a couple of orbits, and set a reminder. This set up. So. And let's watch this deorbit. And that will be all for tonight. I hope you've enjoyed. In atmosphere. Yeah. Prograde and stage everything. Prograde. Prograde then. Yes, the probe core in this is also reversed. And I didn't deploy that. A bit late now. Anti-electric charge. If I aim camera. I don't really need the heat shield at suborbital, but yeah. Can give a tiny bit of fuel. Not that we need that fuel either. Glad you enjoyed. Already coming in. How quickly do we heat up? Not very quickly. Okay. That will get us to land a bit, tiny bit closer to the KSC, which means a tiny bit more money for even the booster. Got my finger over the B button just to... so it would start up the brakes and then immediately retract them. Since we're already out. But then that will prevent them from burning up. Make sure that, there we go, parachutes are staged for one when we slow down. Yep, we are good on the heat. Don't know how much blade trail actually ended up being used. But a neat side effect is even in vanilla, the heat shields do go darken. Can't wait to land your own boosters too. I think I'm still missing some parts to manage it. Yeah, I mean, all you really need, I would say, just put in a fuel tank that you disable the fuel on, just to make sure that if they get into orbit, you can deorbit them. And yeah, just a probe core and a battery and some solar panels. I would say use the static solar panels for the most part, because then you're not going to be at risk really of accidentally not deploying and then not being able to deploy because you've run out of electric charge. I have done that before. Are we going to land? We will land, maybe? No. It's deciding to just rotate, so I think we're going to be landing in the water. Yeah, apart from that, you're not going to be able to recover boosters that you detach too early. If they're falling back through the atmosphere, chances are you won't be able to actually recover it, because it will be in the atmosphere but not loaded, so it will despawn. So actually that's something you could see there with the grid fins and the air brakes. Even with the parachutes, it was falling sideways instead of straight down like this. Now that we've got more drag from the parachutes than from the ailerons and air brakes, this is now the rear of the rocket in effect. That still survived. I guess because it's just barely within physics range. That is going to hit the ground and explode. It did not explode. Okay. I guess I was wrong. Yeah, let's go up a bit. That's another thing. Don't land while you're physics warped. Stop physics warping before you hit the ground. Why? The engine didn't go. The engine did. I pressed Z to turn it on. Why didn't it work? Oh, great. I don't know. Normally, I haven't had this issue in a long time. Don't know what's up with it. Add the fuel. Don't know why the engine didn't light. Oh well. That'll be it for today then. I'll probably leave the streams. I might stream Saturday. I don't know yet. If not, then Tuesday, Wednesday, Thursday is most likely one of those days. I will get this Eve mission ready. Not giving up on that. I mean, I was coming in at 12 meters a second. So, but I was expecting the engine to turn on, and then it didn't. The engine turned on, I think I would have been fine. Not more fine. Yeah. Let's see. Cover that. 60% value, 6,000 funds. But actually, now that I think about it, my usual Friday event was cancelled. I might actually be able to stream tomorrow. Sorry to ruin your sleep schedule. We'll see. I'll try to make the stream announcement earlier if I am planning to stream. Just get rid of all this debris. There we go. Gone. Yep. So, I mean, in any case, we're probably not going to leave for Eve immediately. I'll have everything set up. I'll have the maneuver scheduled. But again, if you look at the alarm clock, you've got Virginia capture in 3 days. Okay, recover that, I guess. Okay. If I switch to that, that's a lot of sixes in the money. Yeah, I'm not going to rush the stream. I'd be announcing it earlier, more in advance. If you miss it, it is on my YouTube. I've got all the VODs there. There should be a link on my Twitch page for that. Yeah, this is my Juno mission. Nearly up the encounter. I'm encountering it in 2 days, and then I've got to into capture. So yeah, coming somewhat close in. Could go closer, but that'll do. My inclination of that's not great. Surprised I didn't fix that in mid-course correction. But yes, this is my zooming is inverted, broken. But yeah, this is my Juno mission. I've basically got 6 relay satellites and 2 scanning satellites. So I'll get this into an equatorial orbit. I think I chose the periapsis to be 3 times the radius, or maybe 2 times the radius of Juno. Yeah, 2 times the radius of Juno. So then I'll be able to put in an equilateral triangle of relay satellites around Juno, and then I'll set up another one around Ike. And then I'll set up a polar scanning satellite for Juno and a polar scanning satellite for Ike. But I do like this tug. The zoom is not working quite properly, but you can see all the midpoints. I've got more struts to connect them to keep things stable, and I've got these were attached to fairings, these floating struts. But yeah, then 4 nuclear engines around the outside. Oh, it's this bug again. Yep, satellite fleet deployer, you could call it that. And yeah, a couple of reaction wheels in there. And then all of these are fairly straightforward satellites. Just got a 100G relay, a couple of solar panels, and then some engines. Kind of engine? Cheetah. But yeah, I didn't want to have the nuclear engine just at the top there. felt a bit weird for how long this craft was. So I've got this, and yeah, this way I've got some structural support keeping everything from jiggly. A shame about the glitch. I think it's because I crashed the previous rocket. It was all the booster was returning to Kerbin. Yeah. I think maybe I haven't done it on this one. See, I think what I've done is the decouplers have no force, and then I've got some RCS thrusters, and I'll just be able to decouple and then push it out the side. And same for. Okay, I do like the line I've got here for the solar, not solar, the polar orbits. So they're scanning satellites. I've also got the surface scanner. I'm not sure if it'll be close enough for Juno, but it should be close enough for Ike. And some science modules all sticking off of it at angles. Ample, extend the beam. So I'll have that extended for the operation. This can also be deployed. Track that way. How can I deploy them to be equidistant in orbit there? So, there is a formula. I don't remember it off the top of my head, but there is a formula. You'll need it to be at least 1.5 times the radius in order to actually be able to see past the surface with your equilateral triangle. You can calculate the actual distance that you need. It's fairly straightforward. Just got it's an inscribed circle within a triangle. Probably look that up too. In any case, what you want to do is you'll have a circular orbit. I'm not actually going to get into a circular orbit, but I'll calculate the period of a circular orbit. Then what you can do is just have a period that's, because in order to get it from equal distance, you just need to have them be a third of an orbit apart in their same circular orbit. So what you can do is you put yourself into an elliptical orbit that's an extra third of a period long. So then you deploy one, you get into circular orbit, you wait an orbit in the elliptical orbit, you come back down, you're now a third of an orbit behind the first one that you deployed. You now deploy a second one, get that into its circular orbit, wait another orbit, you get in the final position, you will have one here, one equidistant here, and you will be in the final equidistant position. I have gone for 2 times the radius just to give myself some extra wiggle room. And that should be able to, with those antennas, they should be able to cover everything within Juno quite easily. Because, I mean, I've got 100% signal strength going from, yeah. Currently, I'm near Juno, and I'm going through a moon station. Wait, no. From the Kia stationary orbit to the moon station to the Kerbal KSP. Yeah, I've mentioned last stream Mike Aben. He does a lot of equations for like rocket science. Literally rocket science, it's the mathematics involved in all of that. So using the knowledge from there and some that I picked up from Wikipedia and KSP Wiki, basically just calculated what ratio of orbital heights you need in order to actually get or equidistance. And so that's going to be the same. You just have an R value that you plug into the formula, and that will get you your correct distance. Keep in mind what you have in your up here. This is your altitude above the sea level. You then also need, if you select Juno, you can pull up the physical characteristics. You've got an equatorial radius. when you're doing your orbital calculations, you need to add that equatorial radius and the altitude to get your actual true orbital radius. So yeah, it turns out with gravity, whether it's a black hole or a large planet, if it's the same mass, it basically behaves exactly the same as if it's a point source of gravity. As long as you're not on the surface, or under the surface. If you're under the surface, then it's basically everything underneath you acts as if it's a point source of gravity. And then everything above you cancels out. Anyway, so yeah, if you're in the center of the Earth, you would be weightless. You would also probably be dead, for various reasons. In case, I hope you've enjoyed. That's where I'll be ending the stream for today. If you're watching this later on YouTube as a VOD, let me know the feedback you have in the comments. And until next time, I will go raid someone, I guess. Until then, see ya.